Hello everyone, this is Atul with Sai. Welcome back to the channel. Today we are learning solid principle I, Interface Segregation Principle in C# using real world banking application example. Interface Segregation Principle says that no client should be forced to implement method it does not use. This helps us to write clean, maintainable and scalable code. So I am opening Visual Studio. So I already created one class, so I will show you the bad example and then I will show you the good example. So bad design, let's see a bad example. Here we created a single interface called IAdminService. Now the custom class is forced to implement ApproveLoan and CloseAccount, which it doesn't need. This causes runtime exception and poor design. Okay. So first I'm creating an interface, public interface, and interface name is IAdminService. Okay, so under that interface I am declaring a method void deposit, then void withdraw, void CheckBalance and CloseAccount, void CloseAccount. So here I am creating one class. The class name is customer, public class, okay, let me cut this code, paste here, public class customer, and I am going to inherit with IAdminService. Okay, so now we need to implement this above 4 methods. Okay, public void deposit, okay, so you can see we have implemented these 4 methods, and here is the deposit logic for deposit method. Here is the withdrawal logic, check balance logic and close account logic. So here I am not showing the actual deposit logic or withdrawal logic. Okay, so this is for example only. One more, void ApproveLoan, public void ApproveLoan. So same error we are throwing here for close account. So now you can see we have created one interface. In that interface we have declared these 5 methods, and we have created one customer class, and we have inherited that interface class into this class, and we have implemented this methods: deposit, withdrawal, check balance, close account and ApproveLoan. Okay, so here is the problem is like you can see the unused methods. Okay, so close account and ApproveLoans. So this is unused method. So customer doesn't approve loans. Okay, so customer doesn't have access to approve the loans. Then we are getting the runtime errors. Okay, if this method is executing, then it's throwing the not implementation error and it is hard to maintain. So interface changes affect all classes. You can see if you change here in the interface, so it's affected in the customer class. Okay, so so this is a poor design, so it violates clean architecture. Okay, so now I will show you the good example that's follow the ISP. Okay, integration segregation principle. So now I am removing these all codes, bad codes from here. Okay, now I am explaining and showing you the good example of ISP. Okay, so we'll split the large interface into small meaningful interfaces. Okay, so so I'm going to implement the segregated interface. Public interface IAccountService. Okay, so we are declaring three methods. Okay, first one is deposit. Customer can deposit amount. Okay, withdraw method. Customer can withdraw money, and check balance. Customer can check their own balance. Okay, so we have segregated this interface with three methods. Okay, so now I am creating one more method, interface. Public interface ILoanService. In ILoanService I am declaring one method, void ApproveLoan, and I am also declaring one more interface, public interface IAdminService. So under this I am declaring one method, CloseAccount method. Okay, CloseAccount. So now you can see in the account service interface, customer can deposit money, customer can withdraw money, customer can check their balance. Okay, in ILoanService, so apply loan, customer can not apply loan, it's ApproveLoan, actually my bad, ApproveLoan. Okay, customer cannot approve the loan, but admin can approve the loan. Okay, and here admin can close account as well in this. So now I am creating one customer class, public class customer, and I am just inherit that customer class with IAccountService class interface. Under this I am going to implement required method that accessible by customer, so customer can deposit money. Okay, console.writeLine. Deposit money, then customer can withdraw money, then customer can check balance. Okay, so we have implemented these three methods by inheriting this interface. So now you can see we don't have the ApproveLoan and close account method for customer, because customer having access only these three methods, like customer can deposit, customer can withdraw, and customer can check balance. Okay, customer cannot approve the loan and customer cannot close the account. So now next part is I will show you the loan offer class. Okay, I'm implementing one more class, public class loan offer. Okay, and I'm inherit with that ILoanService interface. So here I am declaring ApproveLoan method. Okay, so you can see ApproveLoan, and I am going to create a admin class, public class bank admin, and I am just inherit with IAdminInterface. So IAdminInterface, we have CloseAccount method, so we have declare CloseAccount method under that IAdminService interface. So now I am going to implement this in bank admin class, public void close account. Account close. Okay. So good impact for this, so benefit for this clean code, you can see there is no dependency and the code is very clean, there is no dependency. Okay, clean code. So each class has only required methods. So you can see in IAccountService we have 3 required methods, and that consumed by only the customer. So no runtime error, no unused implementation, you can see. So we have declare all the methods, like we have declare ApproveLoan method, we have declare CloseAccount, and we have these 3 methods. Okay, so there is no unused implementation. So all methods are consumer used by our specific category, like for customer can access these 3 methods, loan offer, so admin can approve the loan and admin can close the account. So easy to extend, new feature won't break existing code. In future if you want to add any more functionality, then you just need to create interface like this, and just you need to create one more class, and you need to inherit that class, and we need to declare that method into under that class. Okay, so high reliability, so clear responsibilities, and it's a solid complaint, so proper abstraction here. So we have fixed this using interface segregation. So we divided the interface into account, loan and admin service. Each class now implements only what we needs. Only what we needs. This make a system clean and future proof. So with ISP our code become easy to maintain, scalable, readable and follow solid principle. So that's interface segregation principle explained with a banking example in C#. If you like this video, don't forget to like, share and subscribe. See you in the next solid principle video. Okay, and like one more thing is like regarding ISP, one line answer is, if interviewer asks regarding the interface segregation principle, so ISP state that a class should not be forced to implement interface is does not use. Okay, so thank you for watching this.